Okay, let's just say the word, radiation. For a lot of people, that word alone brings up all sorts of images, from disaster movies to comic book superheroes. But what if I told you that's only a tiny, tiny piece of a much bigger and honestly, a much more normal story?
Yeah, it definitely sounds scary. It's a word we're kind of taught to be afraid of, and, sometimes for good reason. But a lot of that fear, it just comes from not quite understanding what it really is.
Because here's the twist. You are surrounded by radiation all the time. It's coming down from the sun, it's coming up from the ground you're standing on, and it's even in the food you eat.
Yep, this very second. The truth is, without radiation, life on this planet wouldn't even exist. So it's not something to be terrified of, but it is something we really need to understand.
That's the million-dollar question, right? So let's do this. Let's peel back all those myths and get right to the heart of what radiation actually is. So, first things first. I want you to try and forget everything you think you know from movies or TV. We're going to start from scratch with a super simple, clean definition.
That's it, seriously. At its core, radiation is just energy on the move. It's not a green glowing goo, it's not a monster, it's just energy traveling from point A to point B.
And this is so important. The light coming from the lamp in your room, that's radiation. The warmth you feel coming off your own skin, that's infrared radiation. See, the question isn't whether something is radiation, it's about what kind of energy it's carrying.
And that little detail about energy brings us to the single most important idea in this entire explainer. You can basically sort all radiation into two big buckets. Once you get this part, everything else just clicks into place.
So first up, we have ionizing radiation. This is the heavy hitter. It's got so much energy packed into it that it can literally knock electrons right out of atoms. Think of it like a microscopic cannonball. That's the process that, in high doses, can actually damage our DNA. This is the stuff we need to respect.
And then, on the other side, you've got non-ionizing radiation. This stuff has way less energy. It can make things warm up, sure, by making molecules jiggle around, but it just doesn't have the oomph to knock electrons loose or to break the bonds in our DNA.
And this chart really lays it all out. On one side, you've got your high-energy, atom-smashing stuff like X-rays and gamma rays. And on the other, you've got your low-energy waves, like your Wi-Fi, your radio, microwaves. Their biggest effect is just heating things up. One can break things on a molecular level, the other just makes things vibrate. That's the whole ballgame right there.
Okay, so we've got our two categories, but where do they actually show up, in the real world? You might be a little surprised.
Let's actually talk about the high-energy ionizing stuff first. You get a small dose from cosmic rays every time you're in an airplane. It's in the soil, and rocks like granite, and yep, even bananas have a tiny, tiny bit of a naturally radioactive element called potassium-40. It's not a bug. It's a feature of living on planet Earth.
So this brings us to probably one of the biggest fears of the modern age. Our phones are glued to us 24/7, and we've all heard the whispers and worries. So let's just tackle it head on.
Based on everything we understand about the laws of physics, the answer is a pretty clear no. And the reason why goes right back to that key distinction we just learned.
Remember our two buckets? Cell phones use non-ionizing radiation. The energy in those radio waves is literally millions of times too weak to do what ionizing radiation does. It simply can't knock an electron out of an atom or break a DNA strand. It's not even in the same league.
Okay, so even when we are talking about the high-energy, ionizing kind of radiation, it's still not the whole story. The real factor that determines risk is the dose. It's like with almost anything, right? The poison is in the dose. It's all about the amount.
Let's actually put some numbers on this. The dose from eating a banana is absolutely minuscule. A flight from London to New York is a bit more. A chest X-ray, a bit more than that. But look at the average dose we all get just from living on this planet for a year, about 3 millisieverts. Our bodies literally evolved to handle this constant, low level of background radiation.
And when you see it on a chart like this, it really hits home. The dose from a flight or a simple X-ray is just a tiny little blip compared to something like a head CT scan. And that is exactly why doctors are so careful, why they always weigh the benefits versus the risk. It's all about managing that total dose.
So now that we've kind of cleared the air about the risks, let's flip the script. Because when we actually understand and control radiation, it becomes one of the most incredible and life-saving tools humanity has ever developed.
Think about it. We use the very properties of ionizing radiation that could be harmful, and we turn them into something amazing. We use finely tuned beams to literally destroy cancer tumors. We use it to see inside the human body without making a single cut. We use it to make sure medical tools are perfectly sterile, and even to unlock the secrets of the universe.
And this quote just says it all, doesn't it? Radiation isn't a monster hiding in the closet. It's a fundamental part of how our universe works. And when we understand it, it's not our enemy. It's our ally.
So, if you take just one thing away from all of this, let it be this. The power to move past that automatic fear comes from knowing one simple thing. The difference between the high-energy stuff that can change ourselves and the low-energy stuff that's just a harmless part of the world all around us.
From the sunlight hitting your skin to the Wi-Fi signal bringing you this video, radiation is just woven into the very fabric of our reality. So the real question is, now that you know the science behind it, how does that change how you look at all these invisible forces that shape our world every single day?